Everyone. Today I will be talking about how GenAI can be used for creation of simulated data and AI reconstructed data, and what are the ethical problems normally the researcher will face if they use simulated data or reverse engineered data. That what I coined the particular process. So here, no, I think slide is not moving. Okay. In recent years, AI tools have made it very easy to generate large data instantly. So this creates an important question for a researcher like us. Can we really use AI data for serious academic research, especially in social science? This presentation examines that questions by comparing real data and simulated data and the reconstructed data. This is basically my study. I have done a study on this, comparing real data, then synthetic data, simulated data and reverse engineered data. We all know that already in many marketing research, they are using synthetic data. Similar to synthetic data, I want to differentiate synthetic data with simulated data and reverse engineered data. So in my study, in social science research, like collecting real data is very difficult. Okay, because they have to find the respondents and they have to travel a lot. So there are a lot of expenses, and there is a privacy concern because respondent do not disclose their personal matters, and even finding a respondent is very difficult. So alternatively, what happening now is everybody are using, most of the researchers are using generative AI to generate responses, where in generative AI they can immediately replicate the data, and there is no limitation. They can generate 500 responses, or they can generate 1000 response and even 10,000 responses. It immediately do that. And but the question is, the very important risk here is whether whatever the data we generated with the help of GenAI, whether it replicates the real data. So that is the big question. So here in my study, I have collected three type of data. One is actual data using questionnaire, and I particularly this study conducted in rural area of Karnataka. So I collected real data using questionnaire by taking three construct of marketing topic. Then I have selected, I have used ChatGPT and Perplexity AI for generating what we call simulated data by using forward modeling. So here in the forward, what is forward modeling? Here I will provide what ChatGPT or Perplexity, the situation, the simulation, the environment, and I'll ask the data from the GenAI. So it will provide data according to the simulation or the environment what I have asked. And the last one is reverse engineering data. So this is my contribution in my paper. You can see that reverse engineering data means here from the real data, I first generated the result. Okay, so what we call it as a statistic summary of statistics, or in research we call it as output. So from I provide the output to the generative AI, and then I generated data. So that is called reverse engineering data. Then, so in this study, we use real data of 453 responses in Karnataka, particularly South Canara and Udupi district of Karnataka. So here I have, in my real data, I have taken three variables. One is perceived convenience, then trust in e-commerce, then purchase intention. Now using the 5-point Likert scale, and for each construct I have used 4 items, that is called statements, for measuring these constructs. So that is this is the way I collected the real data. Then I went for uh, uh, comparison. Okay, so in this slide you can see this. First, original survey instrument. I created original survey instrument by keeping only 3 constructs, and from that instrument, first I collected original data using human respondent that we call as a real data set, which is ground truth. Then I have used Perplexity and ChatGPT. What I did, I provided certain environment. For example, I gave the prompts. You are the respondents, student respondent of rural area of Karnataka. You have used moderately online platforms for buying and selling. So this kind of my study based on the online consumer behavior. So in simulated data, I have used stratified Monte Carlo sampling method, and it generated, I generated 3 data set, because it is not right to create one data set, because I may get same result as real data because of chance of error or probability of luck. So therefore, I generated 3 different simulated data set, and then then I have used again I have used GenAI. From that, where I have provided SPSS analytical output, like I have provided means, standard deviation, and even mediation effect, then the model fit. So I provided all the original result to the ChatGPT and Perplexity. Then I asked, I want the same result. Can you provide the data set of 453 respondents using ChatGPT and Perplexity? Again, here also I generated total 3 data sets. So you can see here. So what is the problem now? So in this study, I have created 3 different data sets. From the surface level, if you look at my paper, which is available in Google Scholar, from the surface level, all the results are similar compared to real data and simulated data and reconstructed data. The mean, standard deviation, and even reliability all are same. But when you go to deeper level, the result will be different. So this is the what first order illusion, or the summary basic statistics. If you look at the basic statistics of real data and basic statistics of simulated data and basic statistics of reconstructed data, you can see here the perceived convenience or the mean value is 3.98, and in the real data, and in the simulated data, the perceived convenience, the mean value 3.99. Look at in the reverse engineer data, which is 3.99, more or less very close to real data. So that means you can, if you use reverse engineered data or simulated data, you will get exact same result as like real data. But what is the problem in the simulated data and in reverse engineered data? If you have, I used very simple model here. You can look at here, perceived convenience as an independent variable, and purchase intention is a dependent variable, and the trust on e-commerce is a mediating variable. But if you look at the deeper analysis of this model, the model result is different from one data set to another data set. So this is the problem. Of course, you'll get same basic statistic result. The the first order result will be same, but the what we call the causal mediation stress or the causal mediation effect is not similar in all data set. In a real data set, you can look at the result. In real data set, the indirect effect is 39.2% mediation effect, and indirect effect is 27.63. But even, of course, in simulated data, you'll get more or less same result, keeping the same mediation effect. But in reverse engineered data, the indirect effect is very low, and which is statistically insignificant. So this is the biggest problem. Even if you are succeed in the getting a baseline statistics, but you are not able to get that causal relationship between the variable which explained in the theory. So that is the biggest problem in reverse engineered data. And so this study explains why the failure happens. First, there is a collapse in the scale reliability. The items no longer measure the same construct. So this is the biggest problem here. So of course, if you generate one time data from the one model like ChatGPT, you'll get one result. And if you again and again, if you use the same instrument and if you collect again and again, you get different scale. You get a different result, and the reliability and validity of that particular scale will be completely collapsed. And this is called in AI, we call it as hallucination. Okay, it give the data, it result will be the same, but if you do repeatedly, or if you do bootstrapping system in that analysis, you won't get a significant result. Then the subgroup fairness we have done, again, we compare the mean value of particular construct between groups like male and we have taken gender, then we have taken income level of the respondent. We compare the variance of each construct between groups and among groups. So that also collapsed here. So when you compare the variance of a particular construct between groups, it is completely different in real data and in reconstructed data. You can see here, in real data, the mediation is there, both male and female, which is consistent. And again, in simulated data also, which is more or less similar, but in reconstructed data, the mediation is very insignificant and there is a very significant difference. So you can see that. And so what we have to do? So here the warning, AI generated data can replicate first order statistic like means and distribution, but it fails to capture high order causal relationship. So in simple term, if you you can get the shape of the data, but not the real meaning. So you can identify the variables and you can tell what kind of result you want, but it is nowhere near to the real data. So that is the problem. And this is the scorecard, the ultimate scorecard. This slide summarizes the comparison. You can look at the marginal distributions of real data is good and simulated data is adequate, but reconstructed data is worse. Then even in bivariate correlation, if you do bivariate correlation using real data, which is good, and this is adequate, again, this is not good. So similarly, causal mediation, subgroup fairness, scale reliability. Look at the scale reliability is completely collapsed. So this is the why we cannot replicate or we cannot replace reconstructed data for real data. Because why I'm stressing this point? Because nowadays most of the researchers are looking for the generated AI data instead of real data. So what we can do? Finally, the answer is not to reject AI completely, but use it carefully. We need to hybrid approach that combines AI with the theoretical and statistical constraints. This include maintaining a causal relationship, validating mediation effect, testing subgroup consistently, and ensuring the reliability. So all these aspects are very important for research point of view. And AI should be used as a tool, not as a substitute for a real data, not yet, because I know that present version of the AI or GenAI is not at that level which can create data which can replicate the real data. But in future days, I'm not sure, but the growth of generative AI is very tremendous. So in future days, there is a possibility that even reconstructed data or simulated data or synthetic data may replicate the real data. So to conclude, AI generated data is powerful but limited. So it can mimic reality, but it cannot fully replicate it. As a researcher, we must go beyond surface level statistics and focus on causal validity. So only then we can truly cross the reality gap. Thank you.